Welcome, class, to Lesson 7-3. Today, strong mathematicians can learn that the size of a fraction depends on the size of the whole. Please take out your notebook and a pencil. You can write down today's date, the Lesson 7-3, and let's dive right in. And unit fractions, talked about before, the size of the piece, kind of important today. We got numerators and denominators. We've got comparing fractions with the same numerator, same denominator, but it hasn't been that way recently, but yet still a good way to keep in mind. And now to today's lesson as we dive right in. John and his 5 friends want sandwiches. They make 2 sandwiches, one on a short loaf of bread and one on a longer loaf. John cuts each sandwich into 6 equal pieces. His friends think the pieces are not the same size. Are John's friends correct? Write down your guess right now. Do you think they're correct? Well, I would agree with you. Are John's friends correct? You are correct. I would say if I want a sandwich, I want a sandwich from a 6 of a sandwich from this one because this one is bigger than the other one. So if we divide this into 6 roughly, we'll go here, 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 here. Oh, that's really bad. I'm not even going to do that one. If I always say that's why we have a rule in our house. If you're the person who cuts them, the other people get to choose because that way you make all sizes as equal as possible. But that does lead us to this question number 2. What can John do to make sure everyone gets the same amount of food? What would be a good strategy? Well, if you cut them into 6 equally, each person could have a sandwich from here, and they could have a sandwich piece from there, and then everyone should have the same amount of food. So yeah, so keep in mind that if you make things and you're going to cut them in half, the size of what you do makes a difference. Because if they're not the same size, 1/2 is not the same as 1/2, even though they're the same fraction. So let's look at a problem like this. Julio planted 16 daisies and 10 lilies. His goat ate 5 daisies and 5 lilies. Did the goat eat a greater fractional part of the daisies or the lilies? Explain. Well, let's look at his goat. Obviously, one hungry goat. That's what we know for sure. But his goat ate 5 daisies. Well, there's 5. He ate 5. Out of how many daisies? There were 16 daisies possible. And we always like to label things so we know exactly what we're looking at. There's daisies. And then he took on lilies, and there were 5 lilies over 10 lilies that were possible. And we have lilies. So now the question is, which one did he eat a greater fractional part of? Well, if we go and we have our numerators are the same, so maybe I shouldn't have went through that slide so fast. If our numerators are the same, we have to look at the denominator and figure out whatever the smaller one is actually the bigger size piece. Since they both ate the same number of pieces, the size of the piece matters. We know 10 is actually smaller than 16, so 5/16 is less than 5/10, which means, did the goat eat a greater fractional part of daisies or lilies? The goat ate a greater part of lilies. So you can pause the video, write down the drawing, the explanation, and how we kind of broke down those parts to make fractions from numbers in a word problem. A fruit maker sells 2 different packages of oranges. Bags contain 12 oranges and boxes contain 15 oranges. Both packages cost $5. Which one is a better buy? This is like an economic problem. I like this thing. This is like me going to the store trying to find the best deal. Well, which one do you think would give you the best deal? Would it be the 12 oranges or the 15 oranges? Because the price is going to be the same. So we'd have $5 for 12 oranges or $5 for 15 oranges. Well, if you wanted a better deal, the better deal would be, since you're going to pay the same price, you want to get more, so the better deal would be, or the better buy would be 5 for 15 oranges. That means each of your orange, if we would do the math, would actually be about 33 cents per orange. If you ever go to a grocery store, you might see something like per ounce, if you look at tags really carefully to know which one is the better deal. For the one on top, how much would that be per orange? That's a good question. 12 divided by, let's see, if I make groups of 5. Now I'm going to challenge myself. Let's see, how much would each orange cost? Probably more than 33 cents an orange, I'm hoping. Otherwise, my math for the other one's not very good. So let's see. If I have 12 oranges and they cost $5, that would mean each orange would be about 42 cents per orange. So obviously, if I get more oranges for the same amount of price, I would choose the package with more oranges. As long as I'm going to eat them before they go bad. That's always another good issue to keep in mind. But the better buy would be 15 oranges would be the box of oranges. Here we go. Hades' dad ordered one small, one medium, and one large pizza. Why? Just because he wanted to do that. He divides each pizza into 8 equal pieces. Hattie takes 1/8 of the small pizza, and her friend takes 1/8 of the large pizza. Hattie says, so here's our question now. Hattie says she has less pizza than her friend. Is she correct? Well, Hattie has 1/8. Her friend has 1/8. Wouldn't they both be the same? Well, we know that. There's a big difference, though, because 1/8 is coming from the small pizza versus 1/8 of a large pizza. So what does this tell us, or what do these problems tell us about fractions? In order for the fraction to be equal, 1/8 to equal 1/8, it has to come from the same size whole. If it doesn't, then 1/8 really isn't the same as 1/8 because one could be the small pizza and one could be the large pizza, and that wouldn't be the same. So that's a good thing to keep about in mind when we do this. But this was your turn. I was supposed to tell you that. So hopefully you realize that, and you told me exactly what I just told you because I forgot it's already not box 3, now your turn. So I guarantee there's no more freebies. On box 3 now, your turn. You need to solve the following. A shelter had 8 golden retriever puppies and 6 black lab puppies. Cameron adopted 1/2 of the golden retriever puppies, and Judy adopted 1/2 of the black lab puppies. Who adopted more puppies? How do you know? Good luck solving this one on your own this time. And the 4th grade has 3 running teams. Each team has 12 runners. In a race, 1/4 of Team A, 1/3 of Team B, and 1/6 of Team C passed the first water stop at the same time. Which team had the most runners at the first water stop at that time? Explain. I look forward to seeing your answers. Good luck. And if you have any questions, comments, or concerns, feel free to write them down or share them out. Also, any strategies that you use to help you, share those as well. And thanks again for another great lesson and a free answer.